Alright, so good to be back. In today's video, I'm going to talk about copying lists. And so understanding your tools in any trade is essential if you are to do your job properly. And so copying lists might seem trivial, but it's really important if you understand what to expect when you use a different method. Right, so I want to talk about two ways of copying in Python. We have what we call shallow copying, so shallow, and we also have what we call deep. For me to demonstrate these two, I have to create a list. So let me comment this line out. So I'm going to create a list called original here, and I'm going to give it values of 1, 2, 3, 4, and 5. These are just simple numbers for demonstration purposes. All right, so if you are new to Python, you might be tempted to say, this is the duplicate. I'm just giving these descriptive names. So duplicate is original. So what I'm doing is I'm assigning this to this. Okay, this is the name, this is the value. This is the name, this is the value. So since original has a value of this list, if I assign it as a value to the duplicate, I'm going to have this. Okay, so let me print these out. This is how we confirm in Python. So original, and I'm going to duplicate that, and I'm going to say duplicate down here. So if I save and run, down here you see I have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So these two are similar. However, this turns out to be just renaming, because if I am to change anything in the original, it's going to reflect in the duplicate. So the way I can change is, let me say original. I'm going to use append method. .append simply means append some information or some value in the list that I mentioned here. So I want to append something in the original list. So I want to append a 10 in the original list and see what happens. So I'm making changes to the original list, not to the duplicate. But let's see what happens. If I save and run, it's affecting the original and the duplicate, and so it just created a reference to this one, and so whatever changes you make here are going to reflect here. But if you don't want that, there are two ways of copying lists in Python. So we are doing shallow first, and then we're going to look at deep. So the first two shallow methods that you can use, the first one, you use a list function or a list method. This is a built-in method, by the way. And so what we're saying is, this original, we are going to create a list out of it, and so this is going to be a new object, a separate object, not a reference like this. So if I save and run, you can see now these two are different. So whatever changes I make in the original are not going to reflect in this duplicate. Another way is by using another built-in method which is called copy for lists. So name of the list dot copy. So this is the object. So we are copying this to create a duplicate. It's going to create a separate object again. If I save and run, you can see the result is the same, similar to the list function. However, this is what we call shallow copying. Shallow. Okay, so as you guys can see, this is one-dimensional, right? So when something is one-dimensional, we call it shallow. But as you have two-dimensional, three-dimensional, we call that deep. And so what I'm going to do is I'm going to show you why we call this shallow copying. So I'm going to create a list inside here, and I'm going to pass in numbers 10, 11, and 12. So this is element 1, element 2, element 3, element 4, element 5, and element 6. But in Python, we use indices, right? So this is index 0. We start counting from 0. So let me show you what I'm talking about. So okay, let me put these square brackets. This is how we access elements in a list. So if I want to access this element, I'll say it's on position 0. I'm going to comment these two lines so that we don't get confused. So print original 0. Let's see what comes. Save and run. You see number 1. This is on position 1. If I save and run, number 3 is on position 2. Save and run. and this list here is on position 3. So 3, save and run. You can see we get that list. And so we use indices. So index 0, index 1, index 2, index 3. This is how we access these elements. And so if you use just one square bracket like this is one dimensional. But if I want to access elements in here, I cannot use just one square bracket here. I have to use 2 square brackets. So let me show you. So let's say I want to access this 10 here. 3 is accessing this list. If I try and say 4, it happens to be this 4. If I try and access 5, so it happens to be this 5. So how then do I access 11, for instance? So I have to say on index 3 here, inside there is also a list there. So access number 1. 11 is number 1. 10 is 0, 1, and 2. So if I save and run, you see an 11 down here. So this is how we access. So we call this 2-dimensional. This list has become 2-dimensional because it has got a list inside a list. Okay, so shallow coping is going to work for 1-dimensional arrays or 1-dimensional lists, but it's not going to work for 2-dimensional lists. We're going to change this value, and we're also going to change this value so that you guys can actually see what I'm talking about. So at 1 dimension, it's going to work, this kind of coping, but when it comes to 2D, it's not going to work. So these values 1, 2, 3, 4, and 5, they are inside the first level, which is the 1-dimensional, right? 10, 11, and 12, they are now in a deeper level, so they are 2-dimensional. Let's say original. We want to target this position 0, and we want to change that value. This is possible in lists. You can change values by specifying an index and passing in a value. So I'm going to call that first. Let's just call that first. Okay, let's see if it's going to affect both of these lists. And comment this. Let me save and run. I want you to observe down here. This is the first dimension. This is 1D, right? These elements are at the first dimension. So this is shallow coping. So this coping works. Okay, so we copied, but this first, we changed this first, but it did not reflect here. This still remains 1. Whatever changes we make afterwards are not going to reflect in the copied list or in the duplicate. However, when it goes deeper into the second dimension, this copy will not protect us from that. And so let me show you this. So original again. This is on position 3, this list here. And then we want to change the first element here. It's on index 0, and we want to call that second. Okay, so let's look down here. What happens, right? The 1 remained 1, even though we changed it in the original list. This one did not change. Will the 10 change here and here, or it only change here? So let's save and run. See what happens. This second has changed even in the duplicate list. And so it simply means that this copy will not work when the changes are deep in the list. And so this requires us to use deep copying. We have to use a module in Python, import copy. Okay, so this is a module which comes with Python. It's in the standard library. So what we have to do to use this one, you can say copy, meaning this one, which is a module. And in this module, we have a method called deep copy. And so we are just saying copy, deep copy. What are we deep copying? We are deep copying this original, so we have to pass it in here. Original, there. Okay, after we have done this, whatever change we make, whether at the first level or at the second level or whatever dimension we have, is not going to affect the duplicate. Okay, so let me save and run. You see down here, you can see this remains 10. It remains the original. This is the one that we copied. We deep copied this one into a duplicate. And whatever changes we made down here, whether at the first level or at the second level or whatever level that we are going in, is not going to affect our list. And so this is where you need deep copying. So this is the difference between shallow coping and deep coping. So shallow coping just goes one level, and then deep coping, it can go so many levels in there. That's the difference. We also, in this copy, we can also do shallow coping. There's a method called copy. So copy.copy, you can also do that. If I save and run, you can see it does shallow coping. But if you want to do deep coping, you have to use the deep copy method. So save and run. I hope it's making a lot of sense. If you do have any questions, please leave them in the comment section. I hope to see you in our next tutorial. For now, I'm out. Bye-bye.